Hi there, I'm playing with some old stuff again. This time it's an electron tube type BR-2 from Narva, that's a company in the German Democratic Republic. And yeah, it's a CRT, or some people call it a Braun tube, especially around here. In the German-speaking part of Europe, this means attention, be careful. It's a Braun tube, and observe the user manual. So, what's inside? The original user manual, and of course the tube itself. So why it is called a Braun's tube? Normally in English you call it a CRT, a cathode ray tube. Well, Ferdinand Braun invented that tube, or he was most famous for inventing the deflection unit inside the tube. This one has only a horizontal deflection. Normally you have 4 plates, then you have horizontal and vertical deflection. Even the name cathode ray tube is a little bit strange, because when they invented the tube they didn't know about electrons, so normally you would probably say a electron ray tube, but since the rays came from the cathode, so they called it cathode rays. A little bit later they found out it's electrons, but yeah. This tube is not only a CRT, it also has a pretty interesting feature. There is not a perfect vacuum inside, but a little bit of neon gas, and that makes the electron beam visible. And well, let's turn it on. And how does it work? Well, we need 6.3 volts for the heater here. There it is. And we need about 200 volts for the cathode. That's here. And yeah, that's about it. They say the grid voltage here is minus 50 volts. But if I leave that open, we get the full beam. If I put the grid to minus 50, we will block the beam, so that's not what we want. So we don't have to connect the grid, except probably to ground. 200 volts, 6.3 volts, shouldn't be a problem. 6.3 I can take from my lab power supply, and for the 200 volts we need a little bit something special. To generate the 200 volts DC we first need a variac. So we have an AC voltage we can regulate up and down from 0 to about 300 volts AC. But, and now comes the safety part of this video, a variac alone is not a transformer, or most variacs. Well, I think all variacs are not transformers. So that means here on the output you always have a connection to the mains, and that's, as you know, probably, hopefully, it's dangerous. So we need an insulation transformer too. Some of these lab variacs here have an insulation transformer built in. This one doesn't, because a variac is mainly just a large coil that acts like a potentiometer. There is no electrical isolation between the input and the output. And well, that's the insulation and safety transformer I have. So the output of the insulation transformer goes to the input. Oops, cable is a little bit short. Like so. Then the input of the isolation transformer goes to the main socket. Okay, let's see. Have power. Yeah, that works. And of course the vacuum tube doesn't work with AC, at least not that one. So we need a rectifier and a capacitor, and those two parts are inside this little box. Let's connect that. So that's AC output. We go to the AC input of this thing. And then we have positive and negative DC here. And then we connect the tube. First I connect the heater, which is pin 10. That's here. Oops. And the other side is pin 2, that's here. And connect that to my power supply. Then we need the anode and ground. Ground goes to the cathode. That's also pin 10. So let's switch that over, making that negative. It doesn't make a difference for the heater, but it makes a difference for the logic here. Then all the black minus pins, voltages go to the cathode, pin 10, and the anode is pin 12, that's this one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. We don't connect the grid, and that's everything we can connect now. There is one thing more. If the two deflection plates here are not connected, they will probably block the electron beam, because they will, well, suck up all the electrons. And to prevent that, it is recommended, according to the manual, to set them to the same voltage as the anode, both of them, and that acts in fact as some kind of an afterburner, an additional acceleration of the electrons, so that they actually reach the phosphor screen. So I take 2 more red wires, also with up to 200 volts, and connect them here and here. Even the original contact clips here are still in place. That's nice, so it's a little bit easier to connect everything. Yeah, that's it. Let's try it out. And I need also to connect my multimeter so that I know when I have this 200 volts I need. Because the voltmeter on the Variac only measures AC volts, and I have to convert that to DC volts, which are a little bit higher after rectifying and the capacitor. So we should have that too. Yeah, well, DC. Alright, let's turn it on. First thing to do is to turn on the lab power supply. I set it to 6 volts and 500 milliamps. because that's about the current this tube will need. Turn it on. And it starts glowing slowly because the inrush current is a little bit higher, but I limited that to 500 milliamps, and now we are on 6 volts. Maximum is 6.3. I go a little bit below that, and we have now 450 milliamps. So everything we have to do now is to crank up. First turn the isolation transformer on. It has a fan inside. I don't know if that is necessary, but perhaps I will remove that a little bit later. And then the variac, make sure it's on 0. Okay. 11, 28, 48 volts, 60 volts. Can we see a beam? No. 100 volts. 130. I see a green dot. Yeah, I see the beam. The problem is with the lights on, it's almost invisible. So now we have 200 volts. Yeah, we clearly see there is a beam, and I can deflect that beam with a magnet, of course. And you also see here this red stripe here. That's the electron beam made visible by the neon atoms. But I have some better footage and some better images I made with my still camera, and I can show you that right now. I also have another tube that also makes interesting light. It's an RCA OD3A. I don't know, where is it? This here, OD3A. I think you can read that. Made in USA 7604, so that's the date code. 76 is the year. It's a pretty simple device. It only has 2 electrodes. It's a voltage regulator. And how does a voltage regulator with only 2 electrodes work? Well, like a Zener diode. So this is the OD3A, there is a OA3A, an OB3A, OC3A, and the OD3A starts at 185 volts. That's the minimum voltage for it to ignite and pass some current through it. It should then regulate down to 150 volts approximately, so it's not a precise and exact science here. Yeah, let's hook it up. To use it, it is pretty simple. You need a power supply, you need a resistor to limit the current, because when this thing starts conducting, well, it starts conducting pretty well. Maximum current is 40 milliamps through this tube here. And then we have an output voltage behind the resistor. So the resistor drops the voltage because the current here is starts to flow. And we have an output voltage that depends on what type of tube we use here. So I expect something about 150 volts. Let's see if that happens. First we connect positive output of the rectifier. We go to our resistor. Then from the resistor we go to the anode of the tube, which is pin 2. Let me see, that's the diagram. Unfortunately, the center pin here, the plastic of the center pin is broken, but fortunately it didn't damage the glass stem here. Okay, that way. So anode is pin 2. No, anode is pin 5. That's here. And then we need negative to the cathode, which is pin 2. 1, 2. That's here. Is that correct? Yes. And then I take my special socket to have it standing upright. Alright, let's see how that works. Alright, I'm ready to turn on. Let's turn on the variac. Lowest setting is 4 volts, nothing happens at 4 volts. I also connected my ammeter, so to check the milliamps through the tube, because we can't exceed 40 milliamps, so I have to be a little bit careful. Let's crank it up. So we have 50 volt, nothing happens as expected. 100 volts. We have 11 microamps at the moment. 150, we have 15 microamps, and now it jumped on. We have 1 milliamp. Can we see anything? I don't know. Yeah, a little bit. We have 2 milliamps. The voltage is 157. Voltage is still rising. Current is also rising. So we now have about 250 volts at the input, and the tube is now relatively stable at 175 volts. We have now 16 milliamps, 20 milliamps, and that's the maximum of the variac. That's about, I think, 350 volts. On the other side of the resistors, and we have 180 volts at the tube, and it's illuminating. I don't say it's glowing, because it's not glowing, it's It's a gas inside that starts, well, glowing some sort of, but it's not a thermal glow, it's an electronic glow. You also see the color is some kind of purple. Yeah, so the voltage regulator here, this tube, regulates to about 170 to 180 volts depending on the current. It's a little bit higher than the data sheet promises, but yeah, it's an old tube, maybe that's how these things work. Let's see if we can see that glow a little bit better. Yep, it ignited. We go to 15 milliamps. Yeah, looks pretty nice. And if you're still watching at the end of the video here, I have a surprise for you. You can choose the topic of the next video. I have two things. Number one, fire alarm with a break the glass fire button, or that thing here. I just call it the thing because, well, it's a surprise what it is. Maybe you see it, maybe not. So you can choose, write it in the comments if you want the thing or the fire alarm in the next video. Thanks for watching.